Hello, Daniel.
Hello.
Hello, everyone. To those of you watching on X or LinkedIn or YouTube or Twitch or any of the other places we are currently streaming live from, welcome to the Golem EffectTS SDK live stream. My name is John DeGoes. I am CEO of Golem Cloud, and with me is Daniel Vygovsky, the lead engineer on Golem. And Golem is basically it's a durable runtime for agents and their tools. It allows you to build rock solid custom agents, agentic workflows, as well as agent tools that all operate durably, reliably, scalability with fine grained control over permissions, agent level sandboxing, and a host of other features I think that you can check out for yourself on GitHub by going to the Golem Cloud organization and checking the Golem repo. So today has been a long time in the making. You may have noticed that my other company, Zyverge, recently announced a partnership with Effectful. And that partnership is around us becoming the number one premier and actually first sort of training and implementation provider for the EffectTS ecosystem. So Zyverge provides commercial support, commercial training, as well as custom implementation and acceleration services around the EffectTS ecosystem. And that's fantastic. Part of that partnership was us actually committing to invest in the EffectTS ecosystem. And we're doing that in a number of ways. Notably, we are sponsoring at the platinum level the upcoming Effect Days workshop, which is in Italy. I just booked my tickets yesterday, and Daniel, you'll be there. So we'll have a presence at the event and hopefully be giving a fun talk and maybe some workshops there. Remains to be seen, but I'm very excited about that. And of course, Italy in December. That will be nice. So, in addition to that, however, one of the things that we've done is we've built an SDK that is specifically for the EffectTS ecosystem that allows EffectTS developers to quickly and easily build custom agents, agentic harnesses, agentic workflows, or even just like MCP servers and tools for agents using EffectTS. And claim to fame here is, of course, it works on Golem. It runs on top of Golem. So you get all of the previously mentioned features of Golem for free, like durable execution, reliability, pause, resume, isolation, rewind, etc. All that great stuff that folks know Golem does. So we brought that to the EffectTS ecosystem. And today, what Daniel and I would like to do is show you what we've been cooking because we've had this in the works for probably what, 4 months ago, Daniel? 3 or 4 months ago, probably.
Yeah, about 3 or 4. That's right.
Yeah. Yeah. And so it was completed, well, pseudo completed. Of course, nothing is ever completed. We've been continuing to maintain it and revise it and enhance it. But it was completed, I think, probably 2 or 3 months ago. So we've been very eager to show the EffectTS ecosystem what we've been working on. And we just couldn't do it because the partnership wasn't announced. And we were working on some other stuff like the EffectTS workshop that's coming up here in 2 weeks. If anyone wants to be trained in EffectTS 4.0, you can actually just scan that QR code and you can attend my workshop 2 weeks from Thursday that where I will teach you and your coding agent EffectTS 4.0. So before we begin, Daniel, maybe we can talk a little bit about why did we make this? EffectTS doesn't need its own SDK, right? Because EffectTS is just a library or a framework in TypeScript. And it's possible for them to use our ordinary TypeScript SDK. So why did we make this?
Yeah, so actually we had a few live streams, I think, where we tried to do that, and it was working. As I remember, you demonstrated using the Effect AI library with our regular TypeScript SDK in Golem. It just it doesn't feel like a very good experience because in our original TypeScript SDK, you have to implement classes with the async methods. And of course, in those async methods, you can run the effects of EffectTS to be a promise and then return that. And this way you can integrate with the effect ecosystem, but it doesn't feel natural. And also there are many features in the effect ecosystem that we were we wanted to experiment with, providing deeper integration with, thinking of effects own SQL interfaces and tracing and logging and such things. Uh, these are all things that Golem has some counterpart, and it was very exciting to see how we can connect the two and do something that take advantage of both ecosystems at the same time.
Yeah, that's right. So basically friction, right? We encountered a lot of friction and just it wasn't fun and pleasant, joyful and beautiful to use Effect TS together with our TypeScript SDK. So we went all in on Effect in this SDK, and I believe it tries to use something in the Effect ecosystem anywhere it can do so. And the result, I think we're going to show you here in a few minutes so you can judge for yourself. But I do believe that the result of this experiment was a success. And I would even say it's so successful that it's altering the way we're doing our TypeScript SDK. Because in Golem 1.6, we've gone a little bit back to the drawing board and we've scrapped the approach involving decorators and whatnot. And now we're bringing something that looks a lot more like the Effect SDK for Golem to TypeScript developers.
Yeah, we heard some feedback that the decorators were a little bit too magical, I think, because it requires a pre-compilation step, and then who knows what's happening in the
Who said
background.
that? Arnaldi, right? He was one among many people who said that. Michael Arnaldi.
Yeah, that's right. Yeah, so in this effect Golem library, I wanted to experiment with the more idiomatic TypeScript approach and taking advantage of the compiler's advanced type safety features. And it went, I think, well. So that's why we actually, yeah, as you said, we decided to take the same approach with the non-effect TypeScript SDK as well in the next Golem release, but that's not released yet.
All right. Well, fantastic. Why don't you show us the Hello World version? What does it look like to build some sort of like custom agent with the Effect TS on top of Golem?
Let's try to show something. So I will just show the GitHub repo because you will be the one who actually shows this working later. Well, yeah, so it all starts with a define agent function where you can configure various things. You are using fx schema to define the shape of all the inputs, outputs, and the agent's identity, which is called constructor parameters here. As you will see, there is support for binding your agents into externally invocable HTTP endpoints and so on. And you can define agent methods, which are also invocable through various methods from the outside or from other agents. And for each method, you define it with a name and with input and output schemas and optional HTTP bindings and so on. And once you have a definition like this, that's just a value. You can put it in another library. You can reuse it for multiple implementations or for remote connections. But you have to implement it somewhere. And when you call implement on it, then in a fully type-safe way, you have to provide an initialization code, which gets the constructor parameters. And then you have to return an effect, a function returning an effect for each method that you define. All this is type checked even the HTTP bindings and all these root strings, everything is type safe in this definition.
This goes back to the pod or the live stream I did with Michael Arnaldi more than a week ago. Whereas like TypeScript actually is underrated as a language for bringing type safety to practical problems that developers face. And what you've done here is okay, in one place you define all the methods, in another place you implement each one. Actually, that's super hard to do in Scala. It's very
Yeah.
hard to do that. But in TypeScript, it's just sort of the default thing people do, which is really amazing. And it looks like here in this hello world snapshot, you can see we're using schema, effect schema, we're using obviously effect itself. All these methods, including the constructor of your agent, can return
Yes, that's
effects.
right.
And then finally, we're using ref here to manage the state of the agent. So basically, we went all in on effect wherever we could. We're using the corresponding effect data type to help developers. So hopefully, an
Yeah.
effect developer looks at this and they're like, yeah, I know what this means.
Yeah, and I can show a few more examples of going all in for effect. Well, yeah, we can define configuration for our agents, which is also based on effect schema. If you define a configuration type like this, you can access that using it gets from the effect environment. You can get it, and the nice thing is that if you cannot deploy this agent in Golem without providing a type safe value for this configuration. So it's guaranteed that the configuration will be there and the configuration is type safe. Then what else? Oh yeah, the typed RPC clients is also a very important feature.
Maybe before moving to type clients, you could
Yeah,
talk about obviously type configuration is fantastic. The fact that you know it's going to be there and it can't not be there by virtue of the way Golem works is great. But if you are building some sort of agent or agentic workflow, then what are some of the ways you might use configuration to support that use case?
well, I'm not sure what you mean, but you can store API keys and secrets in the configuration, which is something that Golem supports natively. Those secret values are redacted automatically, and it's well not in the current release version, but in the next Golem release, it's also guaranteed that you cannot even force these values anywhere from code, and you can pass around between agents and tools and everything in a very safe way.
Thank you. That provides some great context for folks who are new to Golem.
Yes. So typed clients. So if you define an agent like we had in this small example, we just defined a counter with a single or two methods, odd and get. But you define any kind of agent, you can call that agent from another agent automatically in a type-safe way without doing anything else. So here we go counter is the result of the defined counter method. And you have a client field on it automatically. And this client has a method for each agent method that we define. And also get is the actual constructor method, which returns you the client you can work with. Anyway, getting into too much details, I think. But the point is that all these are native effect methods that are calling the remote agent. It can run on a different executor. It can run on the same node. It doesn't matter. And it's calling the other agent and guaranteeing you exactly once invocation semantics. And there are some nice additional features and integrations with effect, like, for example, effects cancellation is propagated into Golem. So if you spawn a fiber like in this example, and then interrupt that fiber before it's finished, then the other agent receives cancellation and things like that. You can also schedule.
That's super cool because that's not something you get from the Promise one, right? This is a real value
Yeah,
add for the
yeah, that's
effect
one of the new
TS.
features. Of course, if once it's started running, it's not really cancelable, but there is a level of synchronization here. So if it's only scheduled or put in the remote agent's mailbox, basically, then you can still interrupt it and get it out. And even if it's already running, you can still interrupt it, and you just discard its results. So yeah, finally with the effect SDK of Golem, you can properly do things like racing multiple agent calls and choosing one of the results, stuff like that. I already talked about the HTTP routing. I think I'm not going to get into more details about that. Yeah, snapshotting is also interesting and taking advantage of effect in a way, because if you opt in to define your agent state with effect schema, like in this example, then snapshotting is automatic for you. You get a reference to value of this schema, and if you store all your state in that, then it's going to be automatically snapshotted in Golem, which is a technique that we use to speed up recovery of the agent from a suspended state. But of course, you can also write custom code that does the same. Yeah, we have support for storing SQLite databases in these snapshots. I'm not going to the details here.
Just to clarify for folks who are new to Golem, those SQLite databases would be agent specific. So every agent gets its
Yes,
own file system as well as environment variables, as well as, SQLite databases. So everything is agent specific.
yeah. Webhook support is not really interesting from the Effect SDK's point of view, but it's a nice feature of Golem that we support in this SDK as well. You can basically create a webhook with the webhook create effect, and then you can access its URL through a field. Here, you could somehow advertise that URL for a third-party service or human interaction or anything like that. And then you are just awaiting this hook. And once the webhook, these are single shot webhooks. And once it was called, then you just get back the payload that was posted to it, and your agent can resume learning. We have some simple WebSocket client support. And some, yes, this is also interesting because Golem provides support for connecting to Postgres, MySQL, and Ignite databases, which can be used from any of our supported SDKs. But in the Effect SDK, I implemented it through Effect's own SQL client interfaces. So anything that depends on Effect's abstract SQL interfaces can be automatically used with our implementation of these database connectors as well, which is, I think, can be a nice property. And the same is true for the SQLite implementation that we have. So SQLite is also available through Effect's own SQL client interfaces. Yeah, quotas are a way in Golem to define resources with a limited amount of there are various types of quotas, but it can be used for rate limiting. It can be used for limiting or distributing things like API tokens for AI. And it's configurable through Golem's own interfaces and dynamically can be monitored and reassigned and things like that. And the Effect SDK provides support for that as well. And yeah, one more interesting is similarly to the quotas, Golem also allows you to define retry policies, quite complex composable retry policies for various use cases. This is also configurable through Golem's CLI. You can change them for an already running agent without redeploying or restarting anything. And in the Effect SDK, there is a way to convert these to Effect schedules, which is a nice, once again, and something that the other SDKs are not providing at the moment. So you can easily use these retry policies for internal retries or schedules of effects. And what else? Yeah, the last thing I wanted to show is that we also integrated, I think, quite well with effects logging and tracing features. So all the things that you would expect, like affect log info and creating spans with affect everything is propagated into Golem's logging and tracing system, and you can monitor the spans and tracing contexts are traveling between remote agent calls, and everything that you would expect is just supposed to be working. I think that's it. And probably looking at the README file is not that interesting anymore. So I'm stopping the share and
Sounds
giving it
good.
back to you.
All right, fantastic. So hopefully folks have a nice overview of what this SDK provides. And one takeaway I want everyone to hopefully get out of that is just that we have gone effect native. This is not just a simple wrapper or hack around our TypeScript SDK. This is its whole original creation. Doesn't even use the TypeScript SDK. It is truly an effect SDK for Golem, and we're 100% committed to maintain it. And you can see that with the usability and integration into Effect TS, it actually is much nicer and easier to use than our TypeScript SDK, and provides much stronger and much more natural intuitive guarantees. For example, if you're talking to another agent by calling one of its methods and you decide you want to cancel that, you can cancel that, and it will actually not be performed on the remote agent, assuming it hasn't started invocation yet. So that's an example of where, because Effect TS provides such a robust model of concurrency, we're able to go above and beyond what is even possible naively and without paying in the TypeScript SDK. So if you are building in TypeScript, well, hopefully you're already using Effect TS. But if you're not already using Effect TS and you want to build agents or tools or agentic workflows, then definitely I think the Effect TS ecosystem is the best way to do it. And with this SDK, we're providing very first class support for that with a number of, I think, very real world advantages that you're going to see and notice on a day to day basis. All right, with that said, let's go ahead and show you this SDK in action by building something. So, Daniel, we talked previously about trying to build maybe a knowledge graph in Golem.
Yes.
Using the Effect SDK. Do we still want to do that?
I hope so, because I don't have any other ideas at the moment.
All righty, let me go ahead and share my screen. And we will start from a blank terminal and basically walk through how you get the Golem stuff out of your way. And then using a coding agent, I think I'll use AMP for this session, but you could use any coding agent. We will try to build a knowledge graph in our Effect TS SDK that runs on Golem. For those of you who don't know, a knowledge graph is basically a way to represent information in a structured way as a graph. And there's lots of different ways you could do that, but a simple would be like a triple knowledge graph where every piece of information is represented by tuple 3, where you're going to have a subject and a verb and an object. For example, it could be John writes effect TS. And in that case, John would be the subject, the verb would be writes, and the object would be effect TS. So that would be a very simple statement in that knowledge graph. And knowledge graphs are really interesting because they can be used for exposing to agents and allowing agents to answer questions rather than hallucinate them. And they're very good at traversal. You can also do some logical deduction style things. So knowledge graphs, I think, are very important in general in AI. And also, we've recently started using one of these knowledge graph products. Daniel, while I'm getting stuff set up, why don't you talk about our experiences with our knowledge graph?
Yeah, so it's actually working quite well. It's something that we were able to connect our GitHub repositories, our Slack channels, our linear tickets and Notion pages and everything into this knowledge base. And it's indexing everything and providing basically a way for both agents and humans to ask questions about anything, and it's answering questions quite efficiently. And what's nice about it that it's also so it's not just about asking questions by hand. It comes with an MCP server and tools and whatever that you can use in your coding agents. And the coding agents, for example, I'm also using AMP code. It's just continuously turning into this knowledge base whenever it needs some kind of extra context or anything. And so far, we are having a very nice experience with using it. It was
Absolutely.
also answering me the question when I was on a 2 week long vacation recently, what happened in the past 2 weeks, and it was just summarizing everything for me. I didn't even have to talk with my colleagues about it. So very, very useful.
I think if you're not already using it in your engineering team, hopefully across your whole company, but especially in the engineering team, you will be soon because the value of these things is actually very impressive. Not just for you, by the way, but also your agent. So products like Unblocked have MCP servers, so your agent can query the knowledge graph to find answers for specific questions about the code base or the history or design decisions. Anyway, so I'm all ready to go here. And how we start up a new Golem app is we do Golem new, and I'm going to create it in the current directory. And then you can see here, there's a bunch of different languages. We're going to actually choose the effect language. So this is just how we have integrated templates into the Golem command line application. That effect is considered its own language. So we're going to do effect. There's only one template right now. Hopefully we'll get some more templates
Yeah.
by 1.6, I would hope. And it's going to go ahead and create all this. I'm just going to go, okay, it's done. And I am prompted to do two things, Golem build and Golem deploy. I am already running the Golem server on this computer, so I shouldn't have to mess with that. Just go ahead and build this thing and deploy it onto the local Golem server, and then just test that everything is working. While it is building, I can actually show you the code. There's not much here. It is counter agent.ts. And here you can see, what's going on? You can see that DSL that Daniel showed you earlier with define agent. So an agent is being defined here with name, description. It's a durable agent. Constructor parameters. It's actually mounted on an API /counter/name, where name is the constructor parameter. Set cores is set for wildcard, so it's going to accept requests from anywhere. And then it will use our snapshotting mechanism with a schema that just stores a number. And it's going to have two methods, one called value, another one called increment value, just returns the current value and increments it by one, returning the new value. And these are mapped to HTTP routes here. You can see that. So, and then finally, it's actually implemented here. That defined agent is implemented. There's two stages there because you might have an application that uses other agents that need the definitions but don't need the implementations. So you can just include the definitions if you just happen to have to use other agents that are implemented in other modules. Okay, so this is almost ready. It looks like it's done now. It's successfully deployed. So let me walk through what that looks like by using the Golem REPL. So it'll just take a second. Okay, so now I have this is actually a TypeScript REPL. And I can see right now I have a single agent type here. It's called counter. And this is the constructor. And I have to give it the constructor parameter, which is the name. And in Golem, basically agents have a cluster-wide global identity that is determined by the agent type. In this case, the agent type is literally the string counter, as well as the constructor parameter or constructor parameters. Here I have a single parameter, and that's the so-called name of the counter. So what this means is if I call this with two different constructor parameters, then I get back two different references to counter agents that are potentially living on different machines inside the cluster. But if I call it with the same constructor parameter multiple times, I get a reference to the same counter agent wherever it happens to be in the Golem cluster. So that's the way identity works in Golem. I'm going to do let c is equal to await counter.get test counter. And then now I'm going to do c.increment and probably c.value. So this is potentially a agent that is executing on some node in a Golem cluster. It happens to not be right now because I'm running this on my local machine using the Golem executable binary, but it could be a node talking to an agent on a specific node in a Golem cluster. If that agent is sleeping, it's been suspended, then it gets resumed when I go to interact with it. So basically, agents live forever. Of course, you can kill them, you can delete them, you can do all that fun stuff. But by default, agents live forever. And when they're not being used, they're just put in cold storage. So I'm interacting with this agent, so it should be live in memory, running around. Just increment it again and get its value. Everything seems to be working appropriately. So I will do a Golem agent list to make sure I can see that. You can see previous testing rounds produced all this junk, but the specific agent I interacted with has this ID called test counter. That's this one here. You can see it's currently at revision 2, and it was created earlier today, and it is idle at the moment. So all that seems to be working. Anything else, Daniel, I should show off before we get to ripping this thing up?
No, I think that's a good start.
All right,
Yeah,
fantastic.
probably it's well, the agent can do it, but I would start with removing the HTTP bindings and the snapshot things because that's just going to be in the way. It's just an example in the code, and we definitely don't need that kind of snapshotting and HTTP endpoints for our example.
Sounds good. So what I'm going to do is I'm actually going to tell my coding agent to remove all the HTTP bindings from our counter agent. Going into this, AMP doesn't know anything about Golem. However, we've done some stuff to make that easier. Daniel, why don't you walk attendees through some of the stuff we've done to make Golem agent friendly?
Well, the main thing is that we are providing, I don't know, about 20, 25 different agent skills for it's part of our agent template. So if you create a new application with Golem new, there is a .agents directory or agents/skills directory with all these Golem specific skills that are trying to have the agent work with Golem. We also worked on the Golem CLI itself to make it more agent friendly. So its output whenever the agent creates some or like the help pages and error pages, everything is trying to explain the agent how to move forward from what went wrong. It's also showing it detects that an agent was calling them, and if that's the case, then it's providing inline links to these skills, trying to give the agent more context of where to look into how to move forward from a given problem that the CLI reported, things like that.
Thanks for that background. So just taking a look at this. It thinks it's done, but I'm going to have it verify that by building, deploying, and testing. It only did like a syntax or it ran compilation, but didn't actually deploy using Golem. So notably here, I haven't told it how Golem works or how to do any of this binding stuff. And it just very quickly figured that out because all the support that we have baked in here and up-to-date docs, agent-friendly docs, and all that stuff. So we now have, let me just show you what that looks like. This window is freezing for some reason. Ordinarily, NVim is quite snappy.
Yeah, if I don't know if it's only the zoom or not, but it is very slow from this end. It's like everything is 1 FPS,
Oh no.
but we can still see we can still see everything is just feeling very slow for some reason. It's not because of Golem.
Okay. All right. Well, at least NVim is not pausing. I think that's some problem with snacks. I'm not sure what's going on with snacks, but that looks like snacks was hanging. Anyway, you can see here a few things changed about this agent. It's got no more bindings for the constructor, no mount point for the constructor, and no bindings for the method. So this is an agent that's like a pure agent. You actually can't talk to this from from a custom HTTP API. Golem still has generic APIs you can use to construct agents and talk to them and whatnot, but there's no custom HTTP API here anymore because we deleted that. All right, so this succeeded, and now I think we can maybe take a step back. We're to the point where we have an agent, and we need to, and it's working, doesn't have any of the HTTP binding points, and we need to think about if we're going to build a knowledge graph on top of Golem, then how should we structure that? And Golem is a distributed platform. It actually makes it possible to do reliable distributed systems. And it's a fundamental unit of both state and computation is the agent, but it's not necessarily an AI agent. So one of the choices that Golem has made is to use the word agent to represent essentially a stateful a bundle of state and logic that can itself utilize models, but could just have plain ordinary code. And when building an application like a knowledge graph, you're going to need both, I believe. So you have a lot of choices about how you structure your architecture. And for those of you who have any familiarity with actors, with the concept of an actor in distributed systems, then you should feel right at home with Golem agents, because even though Golem does have, I think, first class support for a growing number of like truly AI agentic features, like, for example, tools, which is upcoming in 1.6, permission system around that, and all that fun stuff, quotas for tokens and whatnot. Nonetheless, the fundamental primitive that we provide is actually very general purpose. It's as general purpose as a distributed actor whose state is continuously persistent. So that's one way to think about Golem, is that it provides distributed actors that are scalable horizontally, and it automatically persists their state and ensures that they are run reliably with transactional code execution, and also enables exactly once communication between these actors in a distributed cluster. So these are very hard problems to solve. I can say them in a minute, 60 seconds, 120 seconds, but actually they are very hard problems to solve. And Golem makes it deceptively easy. You would look at Golem and it's just like very simple code and it's all type safe. But the amount of work that goes into making those guarantees actually hold in the presence of nodes going up and down and restarts and updates and new versions of these actors being deployed all the time is non-trivial. It's actually very complicated. I don't know how big our code base is now, Daniel, but I would suspect it's got to be hundreds of
Uh,
thousands.
I'm not sure. I think it could be around, yeah, somewhere between 100 and 200,000 lines of Rust, mostly Rust code, probably, but I haven't checked.
Maybe you should check. My gut feeling is that it's even bigger than that. But anyway, it's a lot of stuff to get right, and it just all comes out of the box in Golem. So if you do have a background with actors, especially distributed stateful actors whose state is persisted and that have guaranteed exactly once communication between them and exactly once execution within them, then take that knowledge of distributed systems using actors into a problem involving Golem, because it will be extraordinarily useful. And Daniel, you've worked with Akka, right, before.
Yes.
um, I have as well. So Akka is probably one of the top actor frameworks out there, I think, or at least was for a while. I'm not sure what the cool kids are using these days, but certainly back in the day and in Java, it was the thing to use. And that all that knowledge is immediately applicable to Golang. So here we want a knowledge graph, and there's a few things that I might want to say right off the bat, which is that a knowledge graph is too big potentially to store inside a single Golem agent, right? That would be one thing that we got to get right out of the gate, because potentially there's a huge amount of information. It's probably too big. And especially if we're designing this knowledge graph to be scalable, it's probably too big to try to store that into a single agent. What are
Yes.
your thoughts on that, Daniel?
Yeah, so that's the one of the things I wanted to say, that when designing how to, or how many different agent types, or how to structure the architecture of this whole thing, one thing is how we want it to be scalable. And in Golem, these agents are quite cheap. You can spawn thousands or even potentially millions of them, not when you are running your Golem server locally, but still you can think of agents that are quite cheap entities that you can just spawn and horizontally scale, let's say infinitely, if you also scale the underlying machines at the same time. But it's in theory it's possible. And the other thing that I would take into consideration is a property of Golem at the moment, that agent invocations are sequential and cannot overlap. That's also affecting the design, in my opinion, significantly.
That's right. Okay. And what would we say? What's like the cap on the amount of memory that a single agent should be consuming before you think about distributing its state across multiple agents?
Well, that's I think when you are running it locally, there is no hard limit. When
Up
in our
to
hosted versions,
WASM, right? Because ultimately everything is running
oh
in
yeah,
WASM
so
sandbox.
yeah, and we are not using or not supporting the 64-bit extension of WASM. So yeah, the absolute maximum is 4 GB. But also when you are using the hosted version of Golem, there are smaller limits for tied to your account, which we are still figuring out. But so Golem itself supports limiting the memory, but when you are running it in your own machine locally, then I think the limit is 4 GB.
And probably you would want to consider distributing well before that,
Yes.
especially working in a language like TypeScript, where there's going to be lots of garbage collection and whatnot. I would say if you're going to be storing more than a gigabyte for sure in a single agent, then you've got to rethink your architecture and think about splitting that up. Hundreds of megabytes, no problem. But when you start getting around a gigabyte, you need lots of room for garbage collection and all the other intermediate data structures that are going to exist in maintaining this bigger amount of state. So, all right. So here's what I'm thinking. Knowledge graph, basic knowledge graph would be organized by triples. And the triples would be basically noun, verb, noun. So it seems to me one of the ways to organize this information would be by having one agent per noun. And basically the noun, the identity of that agent would actually be that noun. So for example, for John, there would be a single agent for me, for my name,
Mhm.
John. And then all of the verbs that might be associated with specific things that I have done or said or whatnot could be stored in that agent. And I think that works reasonably well for two reasons. One, it allows you to partition the entire amount of state in a knowledge graph in some sort of reasonable way. Right? There's could be, I would say, there's could be 10,000, maybe 100,000 different agents. Right? So you're looking at just back of the envelope calculations. You're looking at taking the entire state space and splitting it into 100,000 pieces. So obviously each piece is going to be smaller. But then the other thing I like about that is it allows you to query by noun, which is something you want to do, right? If I want to have an agent traverse a knowledge graph and answer a question about John, it's going to go to the John node and say, look for verbs that are like this. Or maybe it will go like backwards and say, because every noun could either be a subject or an object. So there's actually like almost two sets of arrows, the ones that are pointing into that noun and the ones that are pointing out of that noun. So there's two ways to query that. But in any case, whether you're looking for things done to John or things that John does, then you go to that specific agent and it's going to have methods to expose this information and allow you to query it in some sort of sensible fashion. So it partitions the state space and also it matches the way we want to look up this information. So we are not going to have to do any sort of complex, complicated, time-consuming stuff when we go to query stuff. Does that make sense? Am I thinking about this correctly?
Yeah, it makes sense. Let's go with that.
All right.
Let's start building it.
So we need one agent type for a noun. Could be subject or object. It will store, I'm just going to tell it using use triple store representation when we have subject, verb, object. Not representation, but rather model. You need one agent type for a noun. It could be a subject or an object. It will store verbs the noun does as a subject and verbs that happen to the noun. So that's just very basic description here, which should be enough information for it to build something. Probably won't be exactly what we want. But what I'm thinking is we need this one agent type for noun that's going to store lists of verbs in both directions, outgoing arrows and incoming arrows. And that's going to be the core representation of the knowledge inside the knowledge graph. But that's not enough. And one of the reasons is we're going to want to be able to query this in a high level fashion. We're also going to want to be able to take unstructured information, like plain text, and convert that into structured information and encode that in the knowledge graph. So even once this task gets done and we fix up anything that needs to be fixed up, we're still going to have those two challenges. How do we query this in a sane fashion? Because we don't want to go to a single node and ask questions about that. And then also, how do we take like a whole document and incorporate the knowledge inside that document into the knowledge graph in a structured way? So this is one agent type we need, but the point I'm trying to make is it's not the only one. We're going to need other agents in our architecture for this knowledge graph on Golem. We're going to need other agent types. Do you have any ideas?
Uh, yeah, I think we can introduce an agent that is basically representing a single textual query or something like that. And these could be ephemeral, which means that you, for every question that you type in, there is an ephemeral agent spawned, and its only responsibility is to somehow generate a response for that thing. And in this, we could use directly. Well, it depends on whether we want to cache these things or not. But if we are just writing something simple, we could directly use an LLM and just provide tools for that to query our other agents in our system, for example. That's something that we did in the past in such demos,
Yes.
and
Yeah.
it's
I
relatively
think
simple.
I think you're right. So we need, let's call these like a query agent and a ingest agent. So the query
Mhm.
agent will be responsible for traversing this using AI, obviously, as help, traversing the knowledge graph to answer a question. And the ingest agent will be responsible for taking text and breaking it down into facts and then inserting those or ingesting them into the knowledge graph. We're going to have to use AI for both of those. So fortunately, I already have an open router API key stored in my environment variables, which I can hook up to this Golem application so that we can get AI out of that. All right, so let's take a look at what this did. By the way, we actually have a comment from Michael Arnaldi who says an interesting design is what Cloudflare durable objects are doing, where the state of an actor is stored in an in-process SQLite. So that's an interesting model. The Golem model is a bit different because basically the state of the actor is whatever's in memory, or the state of the agent is whatever's in memory, but not just whatever's in memory. It's also the state of environment variables and file system and everything. So really, from your perspective, as you're sitting here coding inside your agent, everything is part of the agent's environment, and everything, not just the state that's in memory, but also the files in the file system, right? It's that you would access using the ordinary Node.js methods for doing such a thing. All of that stuff is part of the agent state, and it is all stored durably. So it's a bit different, and I would say it's more powerful than the Cloudflare model, but also, of course, with great power comes great implementation tax. And I think, however Cloudflare is implemented, I would be willing to bet involves much more lightweight mechanisms than Golem, because Golem really is virtualizing the entire environment of the agent. And it's done through WASM, so it's super fast. But nonetheless, there's just a lot of machinery that goes into supporting that level of sandboxing. Every single agent has its own file system, its own SQLite databases, its own environment variables, its own everything. All right, so we have here a single agent. Oh, what? Did it
I
do
think
nothing?
it's in a different file, I think.
There we go. Let's see how good this is. We've got a noun agent. We've got get arrows, create arrow, update arrow, etc. And then I'm just wondering how it's encoding directionality. And it is. I see. This is not, this has, I was not precise enough, I don't think, in how I specified this, and it's tried to store all the triples inside a single node.
Did it create a constructor? I mean, a agent ID, which is, or is it a singleton? No, the agent ID is a noun.
Which is correct.
Yes.
But then,
What's the state? Did it use the snapshot feature? Yeah. So there is a noun state type. It's it's to a list of arrows and outgoing and incoming.
oh, okay, well, that's correct. So why does it have, it shouldn't be able to satisfy these type signatures? See, it's updating ref here, forget remote incoming. The signature of this is incorrect because it has verb, object. Oh, I see. So it's assuming that this is the subject, not the object. So create arrow is, this is not what I wanted. Let me just say that each agent of type noun represents a node in the knowledge graph. So there should exist methods on that specific node to, well, identified by the noun itself. So there should exist methods on that specific node to add incoming verbs and to CRUD. Actually, you don't want update. Oh, sorry, you don't want update. Okay, so, and then thinking ahead to our other two types of agents, we want a query agent. Okay, so it's going to fix its mistakes. And then we'll add the following two types of agents. Number one, it's going to have a single method. We'll call it query. It's going to use the knowledge graph to answer a user's question.
Yeah, I would also tell it to make it ephemeral so it doesn't have to think about that.
And while I am typing up this next one, why don't you talk about the differences between ephemeral and durable agents?
Yeah, so durable agents are the default, and a durable agent is what we were talking about so far, that it lives forever, it remembers its state even if it goes out of memory to cold storage. When you are invoking it again, it resumes from wherever it was suspended. So it's these agents that are living forever and remembering everything forever. And it's also what I mentioned earlier, that all of these agents are processing incoming messages one by one, which makes them not a good fit for something like, for example, a request handler, because you don't want all your requests to be serialized, for example. So we also support these other kind of agents, which are ephemeral. And you can think of it like a more like a traditional Lambda function or something I mean an AWS Lambda or something like that, where for every request we are spawning a separate instance of this agent. And it's not it's only remembering its history for observational purposes or debugging purposes. You cannot invoke them more than once. You cannot get them back to life. It's a single shot thing. And it's a very good fit for things like, as I said, request handlers or things that are not really having to have any kind of state that is remembered. Because of this, they are also cheaper and can potentially run a little bit faster, although we are still persisting all the or most of the same level of information that we do for durable agents because we want to provide nice logs and nice debugging capabilities, but that's not used for recovering any state.
Yeah, that's right. So that's one of the major, I think, design decisions you have to make when you're designing an architecture for Golem is, are you going to choose to use durable agents here, or are you going to choose to use ephemeral agents? And here, I think it's relatively straightforward because the query agents, you don't need a single query agent to run durably over an extended period of time and to continue to interact with that same query agent. Really, what we're doing here is, I would almost say, like in Golem 1.6, Daniel, probably we would make a tool or maybe more than one tool for query and ingest.
Yeah, I'm thinking of it's not that straightforward because it depends on how long these queries are. Because if we also
Sure.
want to make sure that we survive any, I don't know, LLM outages or discrepancies while we are running these queries and we want to
That's actually a good point.
optimize for that, then we want to make them durable.
That's actually a good point, which is, if your query takes a long time, then if there's some sort of infrastructure problem or restart or whatever, you want them to continue working unmodified, unaffected by the failure or restart or whatever. So in that case, there would be an argument for making the query agent type durable.
Yeah.
Also, there's another
So
way to structure this, which is not as query, but like as conversation, right? And so you would
mhm.
have a conversation history and whatnot. But my preference would be that should be layered on as another agent. Like if we want like a chat agent here that uses the query agent type, then we should put that somewhere else because it's going to have to maintain the conversation history and do auto compaction and long-term storage and resuming and all that fun stuff.
Yeah. So in a real world version, I would probably do all these AI calling agents, making them durable, and just put some kind of ephemeral facade in front of it that allows multiple requests in parallel and all these interaction things towards users. But
Yes.
that's probably too much for the next 20 minutes.
Yes. All right. So it's having a little bit of trouble here. Embedding an API key, making an API key accessible to these agents, but it should be able to figure out the right syntax for that inside Golem YAML, hopefully without prompting from us. And when this is done, actually, let me see if there's anything else. Oops. There's ingest agent and query agent.
I'm curious if it was using our built-in config support for the model configuration or not.
Yes, you can
Yeah,
see
it was.
here.
I think it was. Yeah.
Yeah. So I had, oh, it thinks it's done without deploying.
Not deployed.
So what it's doing here is I asked it to store the Open Router API key inside a secret. So that's going to be located in model config.
Yeah, that should hold the schema for this, I guess.
Yes. So we've got
And yeah,
query config, which stores the Open Router API key as a secret using schema.redacted and secret string. And then we've got ingest config, and that also uses the API key, but it has a triple extraction prompt. This one will also probably have a couple prompts in here, I would imagine, but we can add that later. Okay, so we've got this working in theory. Okay, so I think the next step here is to implement one of these, or maybe just have it. Just wanted to insert all the scaffolding necessary to use Effect AI to connect to Open Router via this API key. And once we have that, then we'll be in a position where it's going to be time to implement one of these agents. I believe that ingest will be simpler, so probably we should do that. I'm thinking for ingest, what we want to do is have it transform the document into probably maybe comma separated list, basically a CSV, where every line consists of subject, object, verb, or sorry, subject, verb, object. And it's told to only extract statements that should be stored in a knowledge graph.
mhm.
And we can have it do some level of standardization. For now, we won't do any Q&A. We won't have more than one agents checking this thing or any sort of adversarial testing in place. We'll just go with a naive approach, get back a bunch of triples, and then we'll insert those. And they have to
Yeah,
be inserted two places. So every triple has to be inserted two places because of the two nouns involved. The subject noun, it's going to be inserted as outgoing arrow, and then the object noun, it's going to be inserted as incoming arrow. All right, it's still working. So let's talk about, did I miss anything from ingest? I mean, that one seems pretty straightforward.
yeah, it sounded right. Um, yeah, nothing that I don't have anything to add.
All right. So query agent is going to be significantly more interesting because I think what we want to do is we want to give the query agent access to tools that the model can
Hmm.
choose to use to answer the user's question.
Yeah, I would do that.
So that means we're going to be using Effect AI support for tools. What else? And how many tools do we need? I guess,
It has to be only read only, so it's just querying the verbs of a noun or
yes. I think maybe two
something like that.
tools. It
Maybe
could
two.
be it could be querying incoming verbs of a noun or outgoing verbs.
Hmm. Yeah,
Because I think seldom you would be interested in both of those. I'm trying to think if that's true. I mean, it feels true. that whether you're examining the subject or the object really does matter. So that implies you do care about a specific type of verb list in general. I think that's true.
Let's try.
Okay, so it's done. Let's go ahead and okay, so we want to take the text, use the prompt from config to break it apart into triples stored in CSV format.
Do we have a prompt in the config already?
Yes, but it's empty. So
Then we
we'll
should
take a look at
add
that
something.
while it's implementing it. For each line, parse to subject, verb, object, and then insert the triple in the knowledge graph in those two ways. So while it's doing that, maybe I'll open up Golem YAML, and then you can walk us through the formats of this.
Yeah, okay. So it starts with environment, which is different places where you can deploy your application. You can do environment specific configuration and stuff like that. For now, we are using the local server, so it's not really interesting. The next section is components. Components are the build units in Golem. Basically, component is a one WebAssembly artifact that you are compiling to. Here, you can specify some details per component. What the template has is just, it says that this component is using the Effect SDK. That template is something that is embedded in Golem itself and tells the Golem CLI how to compile and package an application that is using the Effect SDK. So we don't have to touch that part. Then there is the agent list, and here we can specify all kind of customization and configuration per agent type. And that's where we can inject configuration. So as you can see, we have configuration for the ingest and the query agent. And it selects the same model for both. And yeah, it has a prompt already. And then there is the last section, secret defaults. It's not per agent. Secrets are per environment. So for example, for the API key, you would have one value that is in the local deployment and another value that is in the production deployment and so on. And all the agents are seeing the same secret key. And what's also important in Golem is that the secrets can be modified dynamically. So you don't have to redeploy anything in order to rotate the API key, for example. And with this syntax in the YAML, you are saying that you want the Golem open router API key secret to be equal to this local environment variable when you are doing a Golem deploy command as a default. But as I said, you can also change it later through the command through the CLI.
Sounds great. Let's take a look at the ingest agent. It says it's done. Sends configured prompt plus document to open router via effect AI. Parses standard CSV, including quoted fields and escaped quotes.
Okay.
Write each triple to the subject's outgoing edges, the object's incoming edges, preserves idempotency, and returns newly inserted triple count and returns a typed ingest error failures. It also moved the secret retrieval to invocation time for key rotation. So that's something I didn't point out about what it was doing before, but it was
I
probably.
think I think it was listening to what I'm saying, I think.
I don't think so. I don't have that plugin into Zoom. That would be fun though, if it can overhear us. I
Yeah.
know, I know. There's work being done on concurrent agents that can like hear things in the background and whatnot, and receive notifications all the time, and that's pretty cool. Then we would be able to talk, and it would be able to listen and eavesdrop and cheat a bit. But actually, what that means here is that when it is going to get the API key, it's happening here.
Yeah.
So that means,
It's
and oh, this is in ingest, right? Okay, so ingest.
yeah.
So every time you call ingest, it's going to go look for the most recent value of that API key, which will allow API key rotation without having to,
Yeah, I
spin
think
up a new
previously
agent.
it was calling it
Yes, in the
in the top of
constructor.
the implement function,
Yes,
which is the constructor.
that's right. Okay, so this looks reasonably good.
Yeah. Let's just
Just
ask
test
the
it.
agent to test it. Yeah.
And then we'll work on query agent. Now, we should actually be able to see quite a lot here.
Yeah, I hope it's not going to create tens of thousands of of
No,
agents
it
or something
will.
like that.
It wouldn't be a live demo without a crash. Okay, so we could see here that almost no agents exist currently.
I think actually there's a watch parameter or something. I don't remember. Mm. Maybe it's only in the wrapper. Oh, or I remember wrongly. Sorry about that. Maybe it was just David's demo.
Oh, it's having trouble because possibly because of old agents.
Mm. Well, no.
Interestingly, all
Let's
these
let's
are
wait.
failed.
Those are counters. We don't even have counters anymore, so it doesn't really matter.
I think we do, but yeah. Or did it delete them? No, it deleted it. It just needs to forcibly redeploy, which hopefully it will figure out.
Yeah, so yeah, should be able to redeploy everything and then reset the states because we have two syn. Well, those are not. Oh, yeah, I think the for some reason we have an older ingest agent which is not ephemeral. We can see it
Ah, yes,
because it doesn't have this UUID attached to its name.
right.
I don't know how
Okay,
that happened.
yeah. And then the other thing is that my API key looks like it's not valid.
Oh.
So I'm going to have to update that. 1 second. Why don't you talk about something useful for folks while I update this
Um,
API key?
yeah, I don't know what to say. Yeah, as you can see in this agent list, we declared ingest and maybe also definitely the counter as the query agent is an ephemeral one, as we can see up there. I think also probably ingest is also an ephemeral agent. And that's why in the agent list, we can see that the one that belongs to the latest revision has this UUID attached. And that's how, even though the agent has no constructor parameter that is in Golem, the identity of the agents, as John mentioned earlier, we are attaching these random IDs to it to distinguish the various single shot ephemeral agent instances, even though there is no user-defined identity that would distinguish them. And then why we are seeing the counter agents being failed, that's a good question. And I have no answer for that. Uh, and let's see. Oh yeah, and if we see what commands the agent was running, that's also interesting. It was, first of all, it was calling the Golem REPL with the script parameter, which is a way that the agent can actually run TypeScript snippets that are talking to the agent. So it can use the REPL by passing short snippets of TypeScript. And it figured it out and used it for testing. And then it was also using the Golem agent oplog command, which is something that we can show in the end. That's a very low level but very powerful debugging tool, which prints every recorded information that we are storing about an agent. And that's not, well, it's a little bit trying to be human readable, but since we are having agents, it's much more usable than before because the agent can actually process that thousands of oplog entries and then figure out what's going wrong with it just by looking at it. It's very powerful. And if I see correctly, the agent was getting the ingest agents oplog, looking for error messages in it with the query parameter, and then it figured out that it was a API key problem, and it even reproduced the problem with curl before telling us that it's an invalid key. So it investigated the problem quite efficiently. How is your new API key going?
Let's see. All right.
Something's happening. There is a new ingest instance.
So it did, I'm not sure what sentence it used.
We can check with the golem oplog command actually that I just mentioned.
All right.
Use that bottom line of the agent list. It's the agent name.
This one here?
Yeah, I think it will be hard to copy paste it because of the new line.
Ah, you are correct.
That's annoying. That we should fix. And probably you need to put it in quotes because of all these special characters.
Yep.
That's still not properly quoted, I guess. I don't know why.
It is single quotes. It's single quotes.
Yeah, I don't know, but that's not a message from the Golem CLI.
You're right. Oh, am I still in the REPL? No, I'm not. I'm not in the REPL.
No. Well, you can just ask the agent to show the oplog of the of that.
What in the world?
Uh-oh.
What is that?
I don't know, just ask the agent. Oh, I meant that ask the agent about showing the oplog, but that's also also working. Very, very good document.
Yes. Okay. All right. So assuming this was the text, then you would expect to see these nodes exist.
And they are.
Yeah. All right. So that's very good. This is not rigorous, but I think we're to the point where we should move on to the query agent. So query agents implement as follows. What else? We need to expose these two tools, and then we need to give a prompt to
Mhm.
the model to use these tools to answer the user's question. Um,
I think, yeah, that should be enough.
okay, so that should allow us to have a basic query agent. Let's just take a look at the ingest one, final state of this. It's going over each of the triples, and it is actually doing our typed agent to agent communication. So keep in mind,
Yeah.
it is it's actually retrieving the subject and the object. These are remote agents. And remember, they're durable. They're identified by this noun here, either the subject or object. So these exist somewhere in the Golem cluster. And now, every time you see methods being invoked on these two references, that is a remote method call. It looks like it's local, but it actually is, in fact, remote. So that is resulting in us storing this information in a distributed fashion. It doesn't look like it, but there's a lot of really fancy stuff happening here. And if this agent were durable itself, then this would be guaranteed exactly once communication between this agent and the other agents that it's talking to. It's doing for each because each one of these things is returning effects. The RPC here is effect integrated, so to speak, even though obviously it wasn't in the REPL. So I guess that's one gotcha you have to keep in mind is the REPL is ordinary plain TypeScript. And obviously our code is using the effect SDK. Okay, so effect AI resolves one tool call round per generation. So I'll use a bounded chat loop, require a graph tool in the first round, continue while the model requests more graph exploration, then force a final evidence-based answer after the exploration limit.
Mhm.
What did I do here? I'm sitting here looking at
I
this,
think
trying
I
to
think
figure.
he used a shell feature that we don't know about.
I'm not a shell expert, but I did something here and I don't even understand. I defined a function in Bash that returns this, but how did I do that? I have no idea. I didn't paste in that big long thing. I actually backspaced and edited it.
Well, but in that one where the first one where you didn't put it in quotes, you had the function parentheses, and maybe that
Oh,
defined the function in
oh
Bash, or I don't
no.
know, something like that.
This is why people hate Bash. One of the reasons.
Yeah, that's why I'm using new shell.
New shell, nice. Wow.
Not that I know its features or syntax or anything, but still, it's not these kind of things are not happening anymore.
Yes. All right. So implemented the query agent. I'm going to
Yeah,
ask to build, deploy, and test. And while it's doing that, let's look at it.
yeah, we should try it with a longer ingested string or
Yes.
something.
Yeah. If this actually succeeds, then I'll have it upload some, like a few pages worth of information. There's like a free like Star Wars wiki or something they can use, or maybe a Wikipedia article.
A small one.
Yeah.
Just like Smotcher again.
So here we go. That's interesting. So the query prompt here is coming from our config, which I told it to use typed config. So it's in the YAML.
Yeah, and then the user's question, and then a
Here's
loop
the
of
agent loop.
already finished with the testing.
Okay.
Oh, that's a
See if it will do this while I'm looking through the code.
I think there are big articles on Wikipedia. It will grab the whole Wikipedia, maybe.
I should have said a small article. Well, we haven't had any crashes yet, so we're due for one. As we
Golem cannot
wrap this
crash.
up, my machine can crash.
Okay. 10,000 characters, it's not that
Hardening.
bad.
The article's apostrophes broke the shell quoting. Okay.
Oh,
That's a testing bug. So the logic here, I was just looking at the termination logic. It's basically saying if you're not calling a tool, then I'm treating this as the final answer, which seems reasonable. Maybe that's not very precise, but
it's supposed to have added 25 triples already. You could
okay.
ask the agent to show the list of agents because your shell is not working anymore. What was it asking? Oh, what did Google introduce?
I'll have it show me the triples ingested. It actually took the knowledge graph article. So
That's
obviously
confusing.
that's in the I know it's in the context though, right? So it had to synthesize, or it had to come up with something that's going to be related to something we talked about. So
So
the
we have a
article
knowledge graph
on
about the knowledge graphs.
you have a
Okay.
knowledge graph that contains information on knowledge graphs.
And we
One
are
thing
using an
though,
AI to ask another AI about the no AI powered knowledge graphs. And
yes, that's right.
it's a very good use of tokens and electricity. And, 'cause, 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 '
Okay, so it's trying to show me the knowledge graph by reconstructing it. I thought it would just show me what it ingested, but it's not going to do that. See, the one
But
thing I was,
I like it because I wanted to see the agent list actually.
well, it's definitely doing that.
Mhm. Yeah, it's saving it to a JSON so it can render it nicely.
Yeah. Okay, there we go.
Mhm.
So knowledge graphs are used to store interlinked descriptions of entity. Well, that's interesting. Okay. That prompt needs work. Wow. Some of these don't even appear to be triples.
I think it's just a new line issue.
Oh, okay.
But
Yeah, you're
I'm
right.
not sure. Or maybe there are comments in the nouns, whatever. Um,
Yeah, the prompt needs work. Also, if this is a 10,000 kilobyte, was it 10,000 kilobyte?
yeah,
It's
9,000
odd to
something.
extract only 25 triples from that. But hey, you could see the basic idea is working here. And we have a knowledge graph that's capable of ingesting unstructured text. Oh, one more thing. Let's just do one more thing.
Mhm.
I don't know if it can figure out how to do that. I mean, it can do the first part, but I don't know if it can figure out how to show me the
I'm,
logs from these agents.
I'm
Anyway,
sure it can.
given sufficient
Not,
time.
oh, it's not that hard.
So we have here ingest, which splits it up into triples. We have query, which uses two tools in order to answer questions in a loop and an agent loop. And all of this runs durably, at least up to us. We decided to make ingest and query non-durable, but it's as easy as, actually, let me just show that right here. It's as easy as changing this string from ephemeral to durable. And this is TypeScript, so all this is type safe. You really only do have two options here for mode. It could be ephemeral or it could be durable. So change these two to durable, and then now you have sort of exactly once execution guarantees, and everything will survive crashes, restarts, updates, all that fun stuff. But even as it is, we do have this reliable knowledge graph. We're actually not storing anything on disk. We're just storing it in memory in the noun agent. It's just an ordinary, probably array. Noun state is two arrays. So we have two arrays here for the noun agent. We're just storing it in memory, but in Golem, it's automatically durable. And in this case, I believe it chose snapshot. Yeah, it did. So it will even come back in like big O of one in the history size of the agent. So that means ordinarily, if you don't turn snapshotting on, then Golem has to reconstruct the state of that agent by replaying all of the operations it did in a deterministic way, and then it recovers the state that way. But if you turn on snapshotting, then it's just instantaneous. So definitely when you can't always do it, but when you can, it's nice to turn on snapshotting. And that
Yeah.
snapshotting will, with or without the snapshotting, though, we have this knowledge graph being durable, continuously existing, and
Yeah, and it's
scaling.
important that you don't have to store your state in this snapshot thing. It's just an opt-in feature
Yes,
that
that's right.
is helpful for faster recoveries.
That's right.
But you can store state in other places as well. And that is also going to be
Yes.
durable. It's just not going to be.
You can have lots of global vars up here. And for example, if you did have lots of global variables, then you would want to turn snapshotting off.
Yeah, because that's not going to be able to recover just from the snapshot if you are storing things
Yep.
in other places as well. But if you turn the snapshotting off, then it's still durable. It's just slower.
And I think if you program in a sane way, you'll always be able to turn snapshots on. But if you want the basically entire state of memory to be durable, then you need to turn snapshotting off. Okay, so the logs exposed a real issue. The incoming test failed because the model chose query outgoing verbs instead of the incoming tool. I'm tightening both tool descriptions and the
Mhm.
configured prompt to distinguish ed direction explicitly. Also request a concise, loggable rationale, not hidden chain of thought before tool calls, since this model supplies no native reasoning field.
And there's the
Okay.
log.
So what does Aster for? Oh, that's the stupid one. What?
It's testing with that for some reason.
It's avoiding failure scenarios. It doesn't want to test the complicated case because probably something will go wrong. But it is doing the right thing, right? It's invoking these
Yeah,
agents using Golem agent invoke.
it behaved correctly, but it's not showing us the logs. Maybe if
Trust
you
it.
open
Trust it.
that, yeah, here it is.
Okay. What are knowledge graphs used for? So basically, it's answering these in one hop. I think you would have to come up with a more sophisticated question to try to force it to answer something that can only be answered if you do more than one lookup.
Yeah.
All right, so here we have it. I think this is working enough to call it a proof of concept. And I don't think let me just check, make sure we don't have any more questions. Not that I see. So anything more we should tell folks about this SDK or Golem before I wrap up?
Well, no. Uh,
So then I'll go ahead and wrap up. So
yeah.
hopefully everyone thought this was entertaining and got something useful from it. I think the takeaways are that our Effect TS SDK for Golem is ready for prime time. It's actually come quite a ways since we first got it working a couple months ago. And it definitely has very rich integration with the Effect TS ecosystem and it allows you to very simply build very sophisticated distributed AI systems. So here we've built a AI knowledge graph that has very strong guarantees, tunable guarantees, basically. And we've done that in an hour. It took us a little over an hour to build this, and it's just amazing just how clean and simple this code is. There's no persistence. There's no boilerplate. We get type safe agent to agent for free. We get native support for schema, effect TS schema, and effect TS ref, and all this other wonderful stuff that's baked in. And of course, we're leveraging Golem's ability to do AI in two places, the ingest agent and the query agent, but also we're using Golem's property of supporting agents as generic bundles of state and logic that don't necessarily have to use AI if you don't want them to use AI to actually store the information content of the knowledge graph, which is very powerful. And what that means is a huge class of applications can be built on Golem that don't need databases. They just don't need stuff. They're just pure Golem. And they just store stuff in memory and they talk to each other and whatnot. Golem is really a fantastic platform for building distributed systems. And now with our first TypeScript support, which we've had for a few months now, and now also with our support for Effect TS, it really is a fantastic platform for building and deploying distributed applications involving AI workflows and AI agents and custom harnesses and all that stuff, because it gives you those reliability and scalability and observability stuff for free and integrates nicely in with your existing libraries. Like we just used all these effect TS libraries. We can just use whatever we want. And we get durability out of that, transactional code execution, all these wonderful properties that Golem is so good in providing. So if you enjoyed this live stream, then please join us on Discord. We would love to see you hop in the Discord channel and say hi. And obviously, you can subscribe to our newsletter on the Golem website, where you can just watch the repo. So we do all of our work out in the open. So you can just go to GitHub and you can watch that repository to see all of the stuff that's coming down the pipeline. We're currently hard at work on Golem 1.6. And Daniel, what's your top feature in 1.6? What are you most excited about our next release?
There are many of nice features in 1.6. It's hard to say one. We are, as you mentioned, we are going to have native support for tools. We are going to have finally streaming invocations. So you can stream input and output of these agent methods, and that works between agents. And also, it's going to implement the durable streams protocol and all these things. We are improving the TypeScript support a lot. There will be a lot of new capabilities, and even more libraries will be compatible, and all these things. And we are having a brand new permission system as well that allows you to fine tune what files, what HTTP calls, what other agents your agent can talk to. And I don't even know. There are so many new features in 1.6 that it's hard to remember.
I guess that's a good problem to have. And one of the highlights that we'll demonstrate in 1.6 is actually a TypeScript coding agent that runs 100% inside Golem with all the durability guarantees. So basically, you'll be able to have a skeleton or a foundation here for an agent that can do anything. You can ask this agent to go talk to Salesforce.com and pull some numbers and put it here and whatnot. And because it will be capable of writing TypeScript and doing all this other stuff and still running inside a WASM sandbox that starts up in 2 milliseconds and that has built-in durability thanks to Golem, it's going to be tremendously amazing. It's like, all the advantages of using heavyweight VMs with none of their drawbacks. You'll be able to do coding agent, general purpose agents that can actually write code and compile it, test it, run it, that start up rapidly, consume almost no memory, can be paused, resumed, execute durably with transactional code execution. That I'm really excited to see. And I'm also excited to see what sorts of things people build on top of that. Because right now, if you wanted to use, and plenty of people do use Golem for building different types of agents, including coding agents, you would have to run the whole build test lifecycle inside a traditional virtual machine. And that just adds so much cost and overhead. And the VM itself is not durable. Whereas in 1.6, like we're giving you something that's going to be super fast and cheap and scalable and can do everything in a totally durable fashion. And I think that's going to be pretty interesting as a sort of way to tie together and show you what is it possible to do now with Golem, with all these features baked into 1.6. It's actually possible to do some pretty amazing things. So hopefully everyone enjoyed that. I will see you online and hopefully see you in Discord. Take care.